Hi guys. So today we're dealing with an alternate area formula for a triangle. So in the past, you've typically had to deal with this formula here, area equals half times base times height, where you actually had to know the perpendicular height and the base of a triangle to be able to find it. If you didn't have these things, you wouldn't be able to find the area. However, today we're going to be dealing with a new formula that also works. So I still want you using this formula whenever you can, but you can also use this one as well. And this one works in different situations when you have different sorts of information other than the base and the height. So in this formula, it's half. So it is half times A times B times sine C. And where the little a and b, the lowercase a and b, are still side lengths, and the capital C is the included angle. Now, the included angle is the angle that's between these two side lengths. So it's really important that it's this included angle that's between. So an example is here. So look at this triangle, guys. You know the base, like the base could be 15 meters, but you haven't been given the perpendicular height straight up to the top. So you can't use this formula here. You have to use this alternate formula. Okay, so we're given two side lengths and the angle in between, and that is exactly what we need. Perfect. So when we have this situation, we can go straight to our formula. The A and the B are our 11 and 15, so they change to those two. And the sine C, well, the C is going to be our angle. So we get this sort of thing that we put into our formula. That goes into a calculator, and you get your final answer to 3 decimal places. Okay, moving on. This question's a little bit harder because I've been given two sides, brilliant, but I don't know the included angle. We are given another angle, and if we use this angle in our formula, it will not work. We need the included angle. So we need to think to ourselves, how can we figure out this angle using these 3 pieces of information? Well, 3 pieces of info is enough to use the sine or the cosine rule. I've got 1 pair, and if I try to figure out this angle right here, that gives us another pair. So 2 pairs allows us to use the sine rule, which is definitely the quickest rule to use out of sine or cosine rule. So with these 2 pairs, we put them into the sine rule formula for finding an angle. So the sines are at the top. We get our theta by itself, and we put this into our calculator to get our value of theta. Now this is this angle here, but remember we're trying to find the area. So we know this angle to be this. Notice how I'm not rounding too early. This is not our final answer, so I don't want to round this answer yet. If I round it, I'll slightly change this number, and it may impact my final answer. Okay, so now that we know this angle and this angle, we can find our included one because they all add up to 180 degrees. So I take 180 and I take away what I've got, and I find out that this angle to be this number here. Again, don't round too early because this is not our final answer. We're just using it to find our area. Now that we've got our included angle, we jump to the formula. The 2 sides are 7.3 and 9.4, so they go in for A and B. And then our included angle is this. This all goes into our calculator, and we get our final answer there. Notice this is, this is where I round. Only at the end do you want to start your rounding. Okay, and one more question. This one's a little bit different. So the idea is that the area of the following triangle is 54 centimeter squares. Determine the value of this theta here. So the idea is that I've given you the area already. We still want to use the formula, but it's about working backwards. If I give you the area, can you figure out the included angle? So the idea is to still start with your formula, but you need to substitute your area for a 54. Notice how your A and your B change to your 12 and your 11 still. So 12 and 11. But your C, your included angle, changes to your theta. And now we have to look at this equation and try to solve it for theta. So I'm going to simplify first. So simplify these three numbers. Half times 12 times 11 is 66. That makes it a little bit nicer to deal with. I want to get theta by itself. I'm going to move the 66 first by dividing by 66 on both sides. That gets me 9 over 11 over here, and sine theta left over. And finally, get rid of sine by doing sine theta to both sides. We get sine, inverse sine of 9 over 11 equals our theta. That in a calculator gives us our final answer to the nearest minute. And that's about it. Good luck with the questions.